All right. Now he told me the problem that people had the most trouble with was the operational amplifier problem. That was the big one. It wasn't meant to be a difficult problem. It's just basic op-amp laws. No current into the op-amps terminals, the input, and no voltage across them. That should do it. So for the first problem, I'll go ahead and do these sequentially. I'm going to try to do it this way. I don't like doing it here on the overhead. Frankly, I run out of room, and my back hurts too. So it says design an Armor difference equation to reject, and they give you a frequency. This is problem one. A frequency to reject 250 hertz, right? And they said that the sampling frequency, or I'm sorry, this is F reject, and F samples is equal to 2,000. All right. And what is the difference equation that should be used to do it? Well, on these things, remember HZ for this one is equal to Y of Z over X of Z. That's Z squared, right? Minus, and the way I think you had it in yours, it's going to be minus 2Z times cosine of omega I, and then plus 1 over Z squared minus 2Z times A cosine of omega I plus A squared. And here, let me just go here, omega I was 2 pi, right, times the FR over Fs sample, so that's 2 pi times 250, right, divided by 2,000. So that's going to be pi over 4. Do you all follow me on what I'm doing here, class? I'm just going right through it. I'm going to go ahead and use the fundamental equation to do this one right off the bat. So for this one, cosine of pi over 4 is equal to 1 over square root of 2. Or you could put 0.707 if you want, something to that effect, just so you knew what it was. After that, when you fill it in for this one, you're going to get y of z, right? And that's times z squared minus 2 times 0.99 times the cosine of that, which is square root of 2, and it's times z, right? And then it's plus 0.98, or just put 0.99 squared. Doesn't, any form was correct. You have that, right? And that's equal to, and I'll have to come down the line, x of z, right? And then it's going to be times z squared minus, well, 2 divided by square root of 2 is really just square root of 2, right? I can leave it like that, times z plus 1. So something like that should show up. I don't know the version. Everybody's going to find a different way to write this, but that's basically what you're looking at. Now, at that point, then you can divide everything by z squared, because z squared is the highest power. It's second order. Z squared is the highest power on z. So we divide everything by that, and then you're going to get simply y of z here. And it's going to be times 1 minus, and this I'll leave as square root of 2 times 0.99 here. And then z to the minus 1. And then it's going to be plus 0.98 z to the minus 2 is equal to x of z, and then it's 1 minus square root of 2 z to the minus 1 plus z to the minus 2. Right there. I'm just going through the motions. Probably some people skip this step, but I'm doing it formally. At that point, then you go back to the actual time domain, correct, class? You're going to go and get a difference equation. Everybody follow me what I'm doing here? All right, this is a problem right out of the homework, by the way. It is the homework problem. It's not even changed. Nothing about this was changed. So at this point, we get simply y of n, right, minus square root of 2 times 0.99, and this is going to be y of n minus 1 plus 0.98 times y of n minus 2 is equal to x of n minus square root of 2 x of n minus 1 and it's plus x of n minus 2. That would be the equation you come at. I asked in terms of y of n, right? So what we do is we take everything and put it on the other side. So I strike this term and take it on this side of the equation and make that plus square root of 2 times 0.99 y of n minus 1 here, and I strike that term and I make that minus 0.98 y of n minus 2, and that's what y of n should equal. Do you follow me on this, everybody? Here's a homework problem. It's exactly, I didn't change anything. The entire homework problem. All right, that's problem 1, and you should have followed that form. Now, some people probably didn't put h of z there. They just put y of z over x of z, and I understand that. But that's the general rule that we do. H of z is the transfer function. It is a ratio of y to x in the z domain. And that was the filter design. Second problem, this is a bunch of DFTs. So second problem, first is simply 0.5, right, to the nth power times u of n. Well, this is the classic problem, right? You can do this in the z domain and then translate the z to just be e to the j omega if you want, e to the j capital omega. But for this one, it can be written as either 1 over 1 minus 0.5 times e to the minus j omega, or you can write it as e to the j omega, right, over e to the j omega minus 0.5. Either one is acceptable. There's nothing, one isn't better than the other and vice versa. Either form's acceptable. The next one was, that's part A. Part B was n times 0.5 to the n u of n. And this is the one where now you're going to have a derivative, right? And you're going to have j. It's j times the derivative with respect to omega of this term right here. Doesn't matter which one you do. You can do 1 over 1 minus 0.5 e to the minus j omega if you want. Doesn't matter, really, either one. When you do that and go through it, you're going to get 0.5 e to the j omega over, and this is going to be e to the j omega minus 0.5 squared. Now, I take it, if you do it this way, you're going to get that form, but you can divide top and bottom by e to the j omega. It's supposed to be an omega. And you'll get it. And that's one form. If you divide top and bottom by e to the j omega or e to the j omega, e to the j2 omega, then you get simply e to the minus j omega there, and you're going to get a 1 there, and you're going to get minus 0.5 e to the minus j omega there. So either one of those is acceptable, and he had all the variations. Follow me in this class? All right, next, after that, part C was n times 0.5 n times the cosine of pi over 3n times u of n. Now, again, there's a lot of variation in how you can come to the answer. You could go ahead and say, I'll take n times 0.5 of n times u of n, do modulation. That's probably the most common way. I'm going to do it that way, but there's a variety of ways you can do it. You could first modulate. You could have 0.5 to the n times cosine of pi over 3n, get times u of n, get the transform of that, multiply by n, have to take a derivative of that, and multiply by j. That's acceptable too. There's a variety of courses you can take to get to the same result. Just understand, he graded the result based on all the possible paths. We'll do. Let's see. I'll do this one. I know that n times 0.5 of n u of n, now that's the one you just did above there, goes to 0.5 times e to the j omega over e to the j omega minus 0.5 squared. I'm going to go with that one first. And what I'm going to do is say this looks like a function that I'm just going to call x of n now. So that looks like my x of n. Now I have the form x of n times cosine of pi over 3n, and that's modulation. That's the one I'm going to use, okay? I can do them all for you want. So now I'm going to have 1/2, right, and then it's going to be the form is x of, and in this case, it's going to be what? Omega plus omega naught, which is pi over 3, right? and that's plus x of omega minus pi over 3. So that's the form I can use. Y'all follow me on this, class? I've already got this as my x of omega, so I can just stick it in. And that means I have 1/2 here. And then I take this, wherever there's an omega, I put omega plus pi over 3. So it's 0.5 times e to the j omega plus pi over 3 over e to the j omega plus pi over 3, as such, minus 0.5 squared plus 0.5 e to the minus j, minus j I'm sorry, pi over 3 over and close that bracket. That form, you could do it, and I mean there's four or five different ways you can get the result. The fundamental thing right there, once you get that, you can just stick in a value for omega. If you let omega be 0, and you can calculate it, and he can check every answer that way, and he did. All right, do you follow me? How many did it this way, by the way? The reason it would make sequential sense, because you already had this, didn't you? So it's just modulation on that signal. That's the way it should have gone. I don't know how many people did it that way, but it was meant to be logically laid out. Yes, sir?
For the multiplying of n, is it minus t over t omega?
It's the derivative with respect to omega times j, right? In front. See me afterwards and we'll go through it. All right, now, and I want to mention this. I don't know how many did it this way, but you'll notice all these functional forms have non-zero values only for 0 and positive n, right? So if you got the z transform for that, you had the dtft by simply replacing the z with e to the j omega. Do you understand that, class? This is a handy tip. All of them, I believe all of them, were only for positive values, right? Okay. All right. How many did it with z transforms and just translated? I figured a lot of you did. It would make sense to do it that way. All right, next part is determine the dtft of the following. And here, for part D, I give you x of omega equal 1 over 2 plus e to the j omega. And then I ask for n. I say, this is part D, by the way. I said, I want to know what n x of n is. If this is x of omega, there's some unknown x of n here. We can get it, but we don't need to, because here the only thing I have to do is put j times the derivative with respect to omega of that. 1 over 2 plus e to the j omega, right? And that goes to, for that one, e to the j omega over 2 plus e to the j omega squared. And then part E was x of n minus 5. Well, if that is x of omega for an x of n minus 5 simply brings out the face of e to the minus j 5 omega times 1 over 2 plus e to the j omega. Do you all agree with that, class? Follow me on this? This is a simple phase. A time delay, right, a step delay turns into a phase shift. How many see this right here? This one. Make sure you understand these and could do these without any kind of hesitation. These are very trivial problems. Remember that. On the final exam, they may be a little bit more difficult. So be aware you're going to have to be, you have to have an understanding of this level fairly well. And I'd suggest you think about z transforms, because it's much easier to do this with z and then translate it back to you. Just let z be e to the j omega. Follow? All right, next, the operational amplifier problem. Here, op amp looks like this. You have minus plus, and Vs is coming here. It's plus to minus Vs. That's plus minus. It's grounded. Between the negative and the output terminal, you have R2. And between here and ground, you have R1. And you have C. And this is V out would be plus to minus V out. And What was asked for was h of s, which is v out of s over v of s, vs of s in this case. So to do this, we go through the basic rules. Don't forget this. On the final, you'll see another one of these. On the final exam, you'll see an operational amplifier problem, probably with a little bit more of a circuit instead of just a simple 3-element. This is one of these things that's kind of obvious when you think about it. Here, if Vs is here, Vs is at that point right there. Do you all agree with me? If Vs is there, this current, and I'll just call it I, is equal to simply Vs divided by R plus 1 over SC. I can leave it like that. Do you all agree with that? If that's the current flowing there, that current must flow here as well. Nothing can flow in and out of the negative terminal. Does everybody follow me on that? You can't make things flow in and out of the negative or positive terminal. And the voltage difference, there is no voltage difference. Whatever is voltage here is here, vice versa. So if that current flows through here, I get a voltage here. I'll just call that V2 is equal to R2 times I. Does everybody agree with me there? Now, the final answer is just going to be V out here would be equal to, start at the negative terminal, I go up to Vs, right? I increase the Vs here, right? And then I have what? Plus I times R2, correct? That means it's equal to Vs plus I here was Vs over R plus 1 over SC there times R2. And that was V out. You all agree with that? At this point, it's sort of over because now V out over Vs, if I divide both sides by Vs, I get V out over Vs, which is equal to the transfer function h of s, is simply equal to 1 plus 1 over R plus 1 over SC. Now that would be acceptable answer. Wait a second, that's R2. Sorry, thank you. And this is R1. My bad. For that. Now, the next thing you can do for this one, and hold on for 1 second. When you look at this, I have the values written down for this. Let's see. R1 was 1,000. R2 was 4,000. Let me go ahead and do this. I'm going to get a common denominator, so I'm going to have... No, I can leave it like that, actually, can't I? I can just multiply top and bottom by S. I have 1 plus, and then it's going to be, if I multiply top and bottom by S, and let's see, divide by R1. So I have R2 over R1 here, S over, and this is going to be equal to S plus 1 over R1C. Do y'all follow me on this? I'm just getting to a point where I have S by itself down here. Everybody? All right, this okay with this? So now I have 1 plus, and then R1 over R2 over R1. R2 over R1 is 4, I believe, S over S plus, and R1C, let's see, R1 is 1,000. Does he have this? This is the solution I gave him. Oh, there it is. Yeah, I'm looking here. I'm seeing different values. Pardon me?
It's 1,000.
It is 1,000?
Yeah. You should have an S over S is 1,000 times 4, I think.
All right, and if this is 1,000, now at that point, it really you can do it several ways. If you wanted to get a common denominator, I guess you could. That is correct, right?
Yeah,
We've done it. At this point, if you're going to do it, you can go back to the time domain. It really, let me just level with you. From here on out, you can do it any way you want, but this should be the form of the answer. Does everybody follow me that is going to be the numerical form? Now, if you want to, you can say 1 goes back to simply delta t right here, right? And then there's a scaling factor plus 4. And then if you look at this, if I have 1 over s plus 1,000, that's simply going to be what? That's e to the minus 1,000 t u of t. And the multiplying by s indicates what? A time derivative, right? If you want to do it that way, you all with me on this?
Yeah.
You can do it, I don't really care how you do this. If you have 4s over s plus 1,000, you can divide. We could do it that way. Numerator top by bottom, in other words. If you want to do it, we can do it that way. We can have s plus 1,000, right? And divide it into 4s right here. Are you with me on this? Multiply, get 4 here. And then if you divide that out, that's 4s plus 4,000 as such. And then you can subtract them, so I'm left with minus 4,000 here. So I would have 4 over, really 4 plus, or 4 minus 4,000 here over s plus 1,000. You can do it this way if you want. I shouldn't even put that delta t there. There's a 1 here. Do you agree with that, class? So it's 1, just leave it as 1 plus 4, or it's 5 minus 4,000 over s plus 1,000. And at that point, I'm just going to go this way. I can see, obviously, I have a delta t here, because that's a constant. Do you agree with me? And here is simply what? A simple decay at a rate of 1,000. Correct, class? Do you all follow me what I'm doing here? This, if that's a constant, that's delta t times 5. Here, it's minus 4,000, right? And then it's times e to the minus 1,000 t u of t. Do you all agree with that? Yes.
So we've got equivalent h of s's here, but they appear to transform into radically different h of t's.
They don't. They don't. Just evaluate them if you see me afterwards.
Okay.
All right. There is no possibility of that happening if they're identical h of s's. Yes, sir. And far back. Go ahead. Yeah.
Where did you get the 4,000?
You see what I did here? I divided top and the bottom, right? Because
Like the value for R2 on that.
it's stated in the problem, isn't it?
R2's given us one.
Can you see it?
I have it right here. It's not in.
Could you bring that to me afterwards? Not now, after class. If there's something wrong with your test, if there's something didn't print out, just come see me. All right? It should be 4,000 for R2, 1,000 for R1. So anything like that in terms of your h of s. In other words, if you get h of s right, then no matter how you do it, you're going to get h of t right. That's the basis of it. All right, now, next. The real problem is this, from what I'm gathering. People didn't know how to deal with the op amp. They didn't know the voltage here was the voltage here. That was the problem. Because if you had that, the rest of the problem falls apart. All right, next. Oh, yeah. So, in problem 4, part A, I give you x of omega is equal to the triangle function of with pi of omega minus pi over 4. And the obvious route you're going to take is duality on this one. I'm just saying that it makes sense to do it with duality. I don't think there's an easy way to do this other than duality. If you tried the inverse integration, it might work, but I'm really wondering if that would work. So if I have this triangle function as such, I'm going to start by using duality, but I'm going to go to the time domain first. Please follow me on this. If you mess this one up, and I don't know what the percentage of people got this one right. I know a lot of people did, but if you mess this one up, just follow me on this, all right? And again, I want you to know something. You can't just topically skim over the homework. You have to understand both the functional forms like pulse, triangle, all those things, as well as how do you implement duality, right? You can't just have one couple of little things and try to put them together. You'll get confused. So for this one, I'm going to start in the time domain the way I usually do with duality. Some of you already know in the frequency domain what a triangle goes to, all right? I know that, but I always start in the time domain, and if I have a triangle in the time domain of with tau of t, that for sure will have the transfer function tau over 2 times the sinc squared of omega tau over 4. Now that I know. All right? That's solid. We know that one. You have to know that one. After that, I know if I have a triangle function minus a in the time domain, what that'll do is cause a phase shift. Does everybody understand that? I put the phase shift there. Everybody follow me? I mean the delay there. You got me on this one? Remember, that delay only appears here. It's minus j omega times a. Follow me? Now, I've got this form looking just like this form, except instead of omega, I have t. Follow me? Now I use, and by the way, this functional form here only exists between minus pi and pi, right? It's actually between minus pi over 2 and pi over 2, correct, class? In the frequency? So I know I can use duality. It's not a question. To use duality, I take the functional form here, and I multiply it by 2 pi. And then, same width, that I'll get to in a second, I replace t with minus omega, right? I'm doing it formally. Follow me on this? After that, on this side, what happens? I take that function, wherever there's an omega, it becomes a t. Correct, class? So this is going to be equal to e to the minus jt times a times tau over 2 times the sinc squared of of t tau over 4. Now again, just fit in the form. Now I'm going to divide by 2 pi on this side as well. So I can get rid of that. And now I realize I have minus omega minus a, and this is the same thing as what? Minus the quantity omega plus a, correct, class? Now you know that the triangle function is an even function, correct? Same thing as a pulse. That means you can get rid of that negative sign right there, can't you, class? So I can. Now I have this relationship. And at this point, I can just map it with this. I take a look at this right here, going to actually this, and I can see the minus pi over 4 is a, right? So a here would be minus pi over 4. Do you all follow me on this one? I can see that the width here would be pi, so that means tau is pi, right? Everybody see what I'm doing? This should be very, very obvious by now. We've done this many, many times. I've got those two things. Now, I can go ahead and put it in terms of t and then an n. But really, at this point, we know t is going to become n. Don't you? Everybody know that? So now I'm going to just write the final answer. So that means my final answer, x of n here, would be equal to e to the minus j n, and a is minus pi over 4, so it's plus pi over 4, divided by, and this is 2 times 2 pi, and tau is pi, so it's really 1 over 4, isn't it, class? If you look at 2 pi times 2 is 4 pi, and you have tau is pi, it's 1/4. Do y'all follow me, class? All right, it's that. Then it's going to be times the sinc squared of now n times pi over 4. And that would be your final form for x of n. And it was meant you're using duality. I don't know what the percentage people got it completely right is, so I can't address this. But this is important on the final. You'll see stuff like this. Look at a. It's minus pi over 2, right? That was minus j. It becomes positive, right? Yeah, only thing I'm doing is wherever there's an A, I put minus pi over 4, and that's it. All right? Next. All right. The final one is, one second. I have an input, x of n. By the way, did anybody recognize this as a homework problem? I hope you did, because I literally ripped this. I ripped 3 of the 4 right out of the homework. Actually, 4 of the 4, if you want the truth. But one had a slight modification, so it wasn't exact. There was a different frequency, but basically they're the homework problems. For this one, I have x of n equals 9 plus 2 times cosine of pi over 2n plus 3 times cosine of pi n, right? So that's the input. And this is my filter that I have. I have 5 times y of n plus 3 times y of n minus 1 plus y of n minus 2 equal to 7 times x of n plus 6 times x of n minus 1 minus x of n minus 2. So now what I'm going to do is take a z transform of that first, if you don't mind. And when I take a z transform of this, I'm just going to pull out the stuff. I have y of z here, and I have 5 plus 3z to the minus 1 plus z to the minus 2 here equal to, and then I have x of z here, because I'm pulling x of z out in front of everything, and I have 7, right, minus z, or excuse me, instead of minus or plus, plus 6z to the minus 1, and then it's going to be minus z to the minus 2 here. And then after that, I'm going to go ahead and get my h of z, but I guess I could multiply top and bottom, or both sides by z squared if I wanted to. Really, at this point, I think I can do this. This is your filter, this is your h of z. And I don't even have to if I don't want to, I think. I can just say, I can do it that way if you want. So that's equal to 7 right there, and that would be z squared plus 6z minus 1 over 5z squared plus 3z plus 1 as such, right? And then you replace z with e to the j capital omega. And in doing so, then I have my h of omega here equal to 7 times e to the j 2 omega plus 6 e to the j omega minus 1 over 5 e to the j 2 omega plus 3 e to the j omega plus 1. That's my filter, and now you evaluate it at the different frequencies. The first frequency where the 9 is would be at 0. Does everybody agree with that? BC is 0, so it's at 0. And that's simply going to be 7 plus 6 minus 1 over 5 plus 3 plus 1. And here, 12 over, and that's going to be 9 4/3. You all agree with that? Next part is going to be h of a frequency of pi over 2. And on that one, what do I end up getting? Well, I have 7 times e to the j, and that's going to be 2 times pi over 2 is simply pi plus 6 e to the j pi over 2 minus 1 over 5 e to the j pi plus 3 e to the j pi over 2 plus 1. And let's see here. That's equal to, well, that e to the j pi is minus 1, so I have minus 7, and then I have minus 5 for starters, plus e to the j pi over 2 is just j, plus j6, right? And then it's going to be minus 1 here, and I have minus 5 plus 1 plus j3 here. Do y'all follow me on this, class? And this is going to be what? That is going to be equal to minus 8 plus j6 over minus 4 plus j3. And by this time you recognize the problem if you did the homework. And you can see that I can factor out the what? The 4 plus j3 out of the top, minus 4 plus j3 out of the top and bottom. Do you all agree with this? And you get 2, don't you? So this one is 2. And then e to the j pi, when we do it, I think I can do this right. I'm going to have to get another sheet of paper, just a second. So when I do e to the j pi, here I get, I'll just put it down, it's going to be 7 times e to the j 2 pi, which is 1. Follow me? It's going to be that, and it's going to be plus 6 times e to the j pi, which is minus 1, so it's minus 6 minus 1 over 5 minus 3 plus 1, and that's 0. So now you've evaluated the transfer function at the 3 different frequencies. The last h, it's 0 at the last one. The reason it's 0 here, if you're wondering, is because 7 minus 6 is 1, minus 1 is 0. And there's a finite value here. It's 0. All right, now you can just plug the numbers in and do it yourself. When you take a look at this, now my final form for y of n here is going to be the DC frequency times the actual, which is 9, right? I mean DC value, times the transfer function at that, evaluated there, and the transfer function was 4/3, correct? So it's 9 times 4/3, plus, and then it's the value of the second term, which was, what was it? 2 times cosine of pi over 2 times n. So it's going to be 2 times the transfer function, which is the value of 2 as well, correct, class? And then it's going to be, and notice there's no phase there to add, so it's going to be times cosine of pi over 2n. And the last one is 0 times anything is 0, so you don't even need that. So that gives me, well, that's going to be 12 plus 4 cosine of pi over 2n. And that should be, that's the answer to that part of the problem. All these, that's a homework problem too. How many remember that as a homework problem? All right, good. Yes, sir.
This doesn't matter, but when you're transferring it to e to j omega, does it matter if you multiply by z squared to start off with, or just do negative?
Either way, no matter what you do, as long as you replace z by e to the j omega. If you leave it as just z to the minus 2 there, it would be e to the minus j2, e to the minus j2 omega. But that's, and there were homework too. It was a fairly easy test. All right, see me with your test. And